All right, we're going to try the no calculator section. I've never seen this section before. Hopefully you can see how I respond to questions and how I recognize when the strategies are going to be useful. Let's just start at the very beginning. Question number 1. College mathematics department plans to spend $1,800 buying computers and books. Each computer costs $300. Each book costs $90. Which equation represents the situation? X is the number of computers. So X computers, and computers cost $300 each. So let's make sure we've got 300 with the X. Oh, that literally only happens in A. So that's got to be it. I don't know what's going on in C and D. This is just not how it would ever go. And then B is just flipping the X and the Y. That is a very common issue with the SAT tests. Is just, can you read and identify the right variable with the right rate? So yeah, definitely A. What is the x-intercept? Well, let's just plug in the points, right? So we know every x-intercept has a y-coordinate of 0, so this is a plug points into equations question. Doesn't matter that I only have half the point. I still can plug in a 0. So y is 0, so 8x plus 0 is equal to 24, right? So 0 here, 6 times 0. So 8x is 24, so divide by 8, and I get x is 3. X is 3. There you go. And I don't expect to get any questions wrong early on here, but I will give you all the answers at the end. I don't know them yet, so we're going to check them at the end, so just stick around in case I get something wrong. All right, which system of linear equations is represented by the lines shown? This is also plug points into equations. Just pick a point and see which one it goes on here. So I'm going to do, it doesn't really matter here. Let's do 0, 2. My guess is 0, 2 will work on the first equation if it works at all. So 0, 2 would be, 2, 0 would be 6 minus 0 equals 6, so that works. And then this would be 4, 0, right? So that would be 3 times 4 is 12, minus 0 is 12. So it's probably A, but let's double check because it might be that the x-intercepts just happen to work in multiple. So yeah, this would actually, yeah, I've already got a problem. So this is going to be 6 minus 0 is 6. This is, so just to be clear, I'm plugging in the point 2, 0 into the first equation and the point 4, 0 into the second. So 6 minus 0 is still 6. That still works. And then this would be 12 plus 0, and that still works. Ugh, this is going to work for all of them, isn't it? 6 plus, oh, no. Right, so this is going to be 2 times 2 is 4. 4 plus 0 is not 6, so this does not work. And then negative 4 minus 0 is 6, so that doesn't work either. Now I guess I should check the 4, 0 point in case they flipped the two equations. That's kind of annoying. Though I already see why it would have to be A anyway. And let's just do that. So if I flip them and do this in the first one, that would be 8 plus 0 equals 6, and this would be negative 8 plus 0 equals 12. So also failure. So look, I can try another point just to see here. Let's just try the point here. This would be 0, negative 3. So if I did that in choice A in the top equation, that would be 0 minus 2 times negative 3 is 6, and that's true because negative 2 times negative 3 is positive 6. But if I did that, oh shoot, it's going to work. See, in my haste to do the strategies here, to show off, I made a mistake of having too much strategy work. So let's try 0, negative 6 in the second equation. 0 minus 2 times negative 6 is positive 12. 0 plus 2 times negative 6 is not positive 12, forcing us to pick A. Now, what should I have seen from the get-go? I should have known that this question was not really testing equations of lines, it's testing slopes of lines. These lines are very clearly parallel. What do I know about parallel lines? They have the same slope. So look, the equations in the choices are not written in y equals mx plus b form. So the slope is very hard to notice. But if you are comfortable with algebra, you should be able to kind of rearrange these, or at least think about how they would be rearranged, and know that in order for these to be parallel, we would need the coefficients to be the same. in both equations. So the 3's in front of the x's, the negative 2's in front of the y's, that's the same slope if I rearrange it into y equals mx plus b. Whereas in choice B, we have the 3's, but this little flip of the sign from negative 2 to positive 2 is going to mean we have different slopes. So we don't need to actually calculate the slope or rearrange these equations. If we understand it conceptually, we can just kind of like get it. However, I'm still happy with my choice of plug points into equations because if you struggle with math, you're probably not going to understand this concept of parallel lines and what it's supposed to look like. So the plug points into equations is a great way of just like saving yourself points if you're not good at math. This is still an easy question. You still want to get these points and get this right. So by taking the points off the graph and plugging them into these equations, you can kind of test to see if the equation works even without worrying about like the concept that makes it a bigger, easier question for people who understand it. So it's a trade-off. It's a trade-off. In this case, though, no matter what, the strategy would save us the points. Let's do 4. The given equation relates the positive numbers a, b, k, and n, which of the following correctly expresses a in terms of b, k, and n. I could also arithmetize here and use a strategy. Let's do it the normal way first. I'm solving for a. So if I had ka plus nb is 10, my first move would be to subtract nb from both sides. I want to get a alone, so that's 10 minus nb. And then to get it alone, we divide by k, and there you go. A is equal to 10 minus nb over k. 10 minus nb over k is choice D. Now, if you wanted to arithmetize, you could pick some numbers here. You could say, all right, what if, it's hard to know. What if everything was 1? Let's just keep it simple. K is 1. Let's use a different color. K is 1, N is 1, and B is 1. Now, I'm not going to solve for, or I'm not going to pick a number for A, because notice how the answer choices have A as kind of this thing off on its own. I'd rather solve for A and see what I get. So 1 times A, or 1 times A, plus 1 times 1 is equal to 10. So that's A plus 1 is 10. So A would be 9. Ooh, my A and my 9 look the same. So that's kind of like what I want this to be. Now I can go to these choices and be like, all right, choice A would be 10 minus, this is a problem, 1 over 1 basically. So there, that works. This is also 10 minus 1 over 1. This is 10 minus 1 over 1. Yeah, okay, so this doesn't really work nicely. And this is maybe a good example of how the arithmetized strategy sometimes isn't more efficient, right? If you know how to do algebra, this is a good example where the algebra is absolutely faster. Now, in order to save this, what I would need to do is start changing some of these values. Maybe looking ahead, seeing how this is going to work, I would change the n and the b to like 2 and see what happens, see if that gives me anything, or maybe change the k to 2. I really don't want to do it to waste your time, so I'm not going to, but we could solve this with arithmetizing by picking numbers for these variables because they don't matter. It's the problem of just like there's a lot going on, and if you're not good at algebra, are you really going to be good about finding the right numbers to pick in this case? I don't really think so. So here's a case where the strategy loses to traditional algebra. Let's move on to number 5. The function f models Jack's pulse in beats per minute as a function of his speed in kilometers per hour on a stationary bicycle. Based on the model, what was Jack's pulse in beats per minute when his speed was kilometers per hour? So, okay, his pulse when his speed is 0. So isn't that right here? 6123? Yeah. I don't know why I would need to do anything else. Kilometers per hour on a stationary bicycle? What was Jack's pulse in beats per minute? Yeah. This feels too easy, but remember, this is a number 5 out of 15 multiple choice questions, so it's supposed to be easy. So just take the win. 6. Triangle DEF not shown is similar to triangle ABC above, where side DE corresponds to side AB. DF corresponds to side CE. So D is here, E is here, F is here, and side DF corresponds to, so yeah, and DE is equal to 2AB. What is the measure of angle DFE? So, rarely on the SAT does the SAT give you, do they give you any information that you don't use. This is a case where they are trying to trick you. The fact that DE is 2AB has nothing to do with the question. if the triangles are similar, the angles are the same. It doesn't matter how big or small the triangle gets. This is just about angles. So they want angle DFE. DFE is going to be this angle down here. So we have 180 degrees in a triangle. We already have 90 taken care of because of the right angle, so that's 90 left. And then just subtract the 37 to find whatever's left over. So this becomes 3 and 5, and there you go, 53. So rare, very rare they give you information you don't use, but this is a very conceptual question, I guess, that you need to understand what a similar triangle is in order to kind of get it right. Which expression is equivalent to this? This feels like a great arithmetize. I sense trouble, right? An x to the fourth, do I really want to deal with that? That's going to be scary. That's going to be annoying. So let's just do something really simple at first and see if it gets us anywhere. Let's make x equal to 0. Now, this probably won't give me the right answer. I don't think it's going to, but I would still do it really fast because that means that this goes away, and we're left with 81 being my value, right? Because 0 to the fourth is 0. 18x squared, that would be 0. So we're really left with 81. And I'm going to see what happens if I plug that in. Am I going to get some choices to go away? Well, choice A would be 0 minus 3 is negative 3 to the fourth. So you can probably guess, once you start doing all the other choices, that 3 to the fourth is 81. And we can get that by doing, well, 3 times 3 times 3 times 3. Well, 3 times 3 is 9. 3 times 3 is 9, so 9 times 9 is 81. And when we do this, we are in fact going to get a positive 81 because negative is going to raise to the fourth is going to be a positive. So that checks out for now. Let's keep going though. If I do choice B, that's negative 3 times positive 3 to the third. So again, I got all the right 3's, but I have that extra negative, so that's going to cause a problem. This is going to be negative 81, so it's not going to work. If we keep moving, choice C, kind of the same problem. Negative 3 to the third times positive 3. Again, the number of 3's is fine, but the fact that that negative 3 is to an odd exponent means that that's going to stay negative. It's only when it's an even exponent that it becomes positive. So this is still going to be negative 81. But that gets us to choice D. This is going to be negative 3 squared times positive 3 squared, and that is going to be a positive 81. So I knew this was going to happen. I had a feeling. So how do we deal with it? Some of you will be able to reason this out at this point and just be like, yeah, it's probably going to be one or the other. But if we didn't know that, we could just pick a new point. I'm going to try 1. I really don't know if it's going to work. I've never done these questions before. Let's pretend x is 1. So I'd have x to the fourth, that's 1 to the fourth, minus 18 times 1 squared plus 81. So that's 1 minus 18 plus 81, right? So I would do 1 and 81 first is 82 minus 18. So that's what? 82 minus 20 would be 62. This would be 64. And that's positive. So I don't know. Let's see if this works. That's my new answer. I know that B and C don't work, so I don't have to try them again. So A would be 1 minus 3 to the fourth. So that's negative 2 to the fourth. So negative 2 times, or negative 2 squared would be 4. Times 2 again would be 8. Times 2 again would be 16. So this is 16. That doesn't look good. But let's try D. That would be 1 minus 3 squared. 1 minus 3 squared times 1 plus 3 squared. So that's negative 2 squared times 4 squared. That's 4 times 16. So 2 times 16 is 32. Times it by 2 again, and that is 64. Yeah, 64, yes. Oh boy, I'm having a brain fart here. So there you go. And so that's how I know it's right. I know we had 81 before because we switched numbers. We have a new number that we want, and so we're looking for 64. That's where I almost went wrong. And that's why with arithmetize, you can get questions where you don't know the algebra, but you've got to be really careful with your arithmetic and stay organized. It does get tricky and does get annoying. So just be careful. But there you go. That's definitely how I would have done that in real life. Which expression is equivalent to this? Okay, so here also looks like we might be able to arithmetize, but fair warning, anything with exponents is going to be very difficult to arithmetize on the no calculator section because our brain is not good at exponents beyond what we just did in the last one. So here, we got to just know the rule. So if we did g to the 4/5, It's the fifth root of g to the fourth. Okay? The same thing happens with the h. That would be the fifth root of h squared. So the bottom of the fraction is the radical, right? The root. So remember, the roots of a tree are on the bottom of a tree. The roots of the exponent are the bottom of the exponent, so the fraction. So it's annoying. But this can be combined because they're both fifth roots. We can just put it both under, and that's g to the fourth h squared, and that's choice B. So all of these others are just messing up the exponents. All right. This is a great one. I'd be excited to see number 9 because this is a plug points into equations question, right? So don't think about how these graphs are going to look, how these equations are going to look if we graph them big picture. Just narrow your focus, smaller. What would they look like at a particular point? So we see the graph has this point here, and be careful, it's a little bit of a trap. This is the point 0, 2, right? Look at the scale, 2, 4, 6, 8, 10. So we need to see what happens when we plug 0 into all these equations. Which one gives us 2? Well, in choice A, 3 to the 0 is 1, so that doesn't work. That's why it's a trap. People pick that. 2 times 3 to the 0 would be 2 times 1, so that's 2. That works. 2 to the 0 is 1, right? Everything to the 0 is 1. And then 3 times 2 to the 0 would be 3 times 1. So there you go. It's got to be B. And that's why plug points into equations is so amazing. All these other answers are very trap-heavy answers. So the kinds of things that you would put if you were just thinking about it conceptually and like looking for a y-intercept, misreading the scale. But if we just take one point and plug it in, it's obvious what the answer is. All right, let's do one more here. Let's do 10, then we'll split this up. Getting kind of long. What is the solution to the given equation? Obviously, guess and check here. Gosh, do not, under any circumstances, try to solve this algebraically. Just pick something. Let's start with C because it's the easiest number. So the absolute value of 3 plus 2 equals the absolute value of 3 minus 8. So the absolute value of 5 is equal to the absolute value of negative 5. That is true because remember what an absolute value does. It turns a negative number into a positive number. And so these are both just 5 equals 5. So look, I started with C because it was the laziest number. And it paid off. It was the correct answer. So let's see if we got the right answers to these numbers 1 through 10. As expected in this section, I have so far gotten nothing wrong on numbers 1 through 10. These are the easy and medium difficulty questions. You would not want to get anything wrong here because this is where the easiest points are going to be. I will say, just as a kind of point of commentary, I did think that number 3 was kind of hard for number 3. That seemed a little intense. If you're not great at algebra, number 4 seems a little scary. But the rest here is really just a little bit of memorization, a little bit of strategy. If you don't know how to memorize these rules for exponents, you're going to be kind of out of luck with number 8. But if you understand the strategies, these 2 very difficult questions, actually these 3 difficult questions, 7, 9, and 10, all are absolutely must-get questions for everyone because the strategies work so well. We have arithmetize in number 7, we have plug points into equation in number 9, and we have guess and check in number 10. There is no reason to be doing complicated algebra here. Use numbers, see how these equations work themselves out, and then you will get the answer without having to memorize a million rules. It's much easier, much better, and it works really well in the no-calc section.